Okay, today again, Tuesday, July the 21st, 2020. We have our 2100, our FCOG1200 board. We have schematic E640 REV K. And again, we have the same setup. The only one parameter that Tony corrected me is that we're applying 480. 480 comes into a transformer. We just step it down and 2 to 1 to 240, and that's where we're bringing it into 240 here. In this particular case, and we have two sets of 240, the one shifted and the one for the X, the one for the Y, shifted 30 degrees. What we have on our board, we have these post modules that are even in socket. This is an engineering board, and we have an internal 2 meg ohm resistor, and that's how we're showing it. If we had a 240, we could have used another post module that has a 511K. That's why in your case we recommended at 200K if your voltage is 120. And as I'm going to prove it, those voltages will work because this is the most forgiving part of the circuit as far as the amplitude. So Tony has started the board. We have enabled the board. We have a SIG high. We don't have an output. Go ahead and just turn it on really quick, Tony, just to make sure that, again, we're not looking at the output, but and we can see the signals. I will look at those signals. But go ahead and you're at 275, your maximum. So go ahead and bring it back, Tony. And we'll see some distortion there. And go ahead and bring it all the way to 0. All right, and then you're at 0. You're not firing. So what I've done is I have on J7, because I'm bringing in the phase references from the post modules, I have this J7 free, so I can look at it, and I'm using this to monitor. So I have on channel 1, I have pin 1, which is my AX. That's the attenuated phase reference from the X bridge on the A phase. I have the BX on position 2, and the 3 on position 3. We have the CX, all from the X bridge. And we can see here that we have the 120 degrees phase shift from one and the other. If I wanted to bring them together, I could see here the 120, and there you go. So here, every once in a while, depending on whether they are showing 118 degrees, bearing 118, 119. So let me bring this back. Now the other thing that I'm going to put it up my zero. The other thing that I want to point out, in addition to the correct facing, is that this is the 0, and I am biased at 5 volts. I'm biased. This is my 0. The waveform is biased at 5 volts, which is the first division, because I'm at 5 volts per division. The same thing here. This is my 0. This waveform is biased with DC volts, DC, and the same thing here. On the 5 volts DC, I have there my waveform superimposed. With 240, with 2 mega ohms internal into this board, the resulting peak-to-peak voltage is 2.70, 2.8 volts for this signal. So at 240, we can do the simple calculation at 120 with a 200K. You're getting a signal that it's going to be, as long as we are within 6, 7, 8 volts peak to peak, we are okay. As long as we're in the 0 to 10 volts envelope, we are okay. Here the most important thing is the sequence. And now what I'm going to do is I'm going to eliminate position 4. I'm going to get rid of your inhibitor, right, John?
Yeah.
I'm going to get rid of channel 4, and I'm going to move 3. So all I have right now, and on it touch, I have my AX, and now I want to move to position 4 to my AY. 1, 2, 3, and 4 right there. 4, 5, 6, 7, 8. And this is an 8 position. So right there. Now what I'm showing is now this is the A, this is now the AY, and what I could do is I could come in here and verify that I have now my 30 degrees, and if I were to measure this, there's again 27, 28, 30. 30 degrees spacing between the A and the B. But at the end, we've noticed that in the output we have the 12 humps from the 12 SEO. So this is This is the end of this video.